Okay, here's section 7.4, inequalities. This is a pretty fast section, but we might as well give it its own little video here. Not much to it. Suppose you have this sort of an equation. X is less than 7. What does that mean? This is a sign for less than. It basically means if you have a number line, say here's a number line with 0, 1, 2, 3, 4, 5, 6, 7, right there, continuing on, 8, 9, 10, and so on, negative 1, negative 2, negative 3, negative 4, negative 5, okay? Then x less than 7 means that you are somewhere on to the left side of 7. Here's 7 right there, and you can draw a little parentheses mark there, and you're somewhere to the left of 7. That's all that means. Okay? If you have this means less than or equal to 7. So that means you're not only less than 7, but you include the possibility of 7. So then we put a little mark like this. So this, another way of writing this is to say x such that x is somewhere, remember the symbol for element of, it's somewhere in the interval from minus infinity to 7. That's what that one means. If you put this there, then it means this, which includes 7. So this includes 7. If you have just an open parentheses there, it does not include 7. Okay? So let's try something else. Let's say you have this. X is greater than negative 4 and less than or equal to 5. Okay, what does that inequality mean? It means you want all the x's such that x is an element of the interval from negative 4, because you want to be larger than negative 4, and here is 5 right there. You want to be less than or equal to 5. So you want to be somewhere from negative 4 to 5. So you want all the x's which are greater than negative 4, but less than or equal to 5. So you would express it like that. Okay? So these two things are saying exactly the same thing. If you have x is greater than 8, what does that mean? That's all the x's such that x is where? It's somewhere from 8 all the way out as far as you can go. So that's a sign that says we're going out to infinity, we're never stopping. So anything greater than that. Again, if you have greater than or equal to 8, then you would include that. Because then you're including 8. Then it would be everything from 8 on up. Okay? So that's a quick explanation of inequalities. Then let's go ahead and solve some inequalities. So for example, suppose you have 3x is greater than 12, and you want to find out, what does x have to be? Well, it's easy enough. You just divide both sides by 3, and you're going to get x is greater than 4. So there you've solved it for x like that. Okay? How about this one? What if you have negative 3x is greater than 12? Then you can divide both sides by negative 3. Okay? And we're going to get x on this side. 12 divided by negative 3 is negative 4. But notice that I'm hesitating on what sign to put in there. Let's see once why I'm hesitating. If you have 1 is less than 3, do you everyone agree that 1 is less than 3? What happens when I multiply both of these by -1? Here I get -1. Well, let's first multiply them by 2. If I multiply it by 2, I get 2 is less than 6. That's true. If I multiply it by 5, I get 5 is less than 15. That's all true. No problem there. What if I multiply it by -1? If I multiply it by -1, I'm going to get -1. If I do it the same way as before, I get this. And notice that while these were both true, this is not true. Agreed? Here's 0, here's 1, here's 3. 1 is less than 3, but here's -1, and here's -3. Notice that -1 is what? -1 is bigger than -3. See that? Similarly, if I multiply this by -2, what would we get? -2, -6. What's the relationship between -2 and -6? Let's just change those. -2 is bigger than -6. So the key is, whenever you multiply or divide by a negative number, you have to switch the sign. Here the sign is bigger, so now it's got to go less than. If I started with less than, then it becomes bigger. Either way, you need to change the direction of the inequality. Okay, so that's a key thing. If you forgot it or didn't know it, important to know. Okay, just a couple more. What if you have something like this? What if you have 3x minus 5 is, say between, I don't care, let's say 10 and -2. Okay, let's just do that. Anything you want. So to solve this for x, we would first add 5 to everything. If I add 5 to everything, same idea as when you work with equalities, you just have to do it to 3 things rather than 2. So let's see, this is going to give us what? 3 is less than 3x is less than or equal to 15. Oh, I happen to choose nice numbers here. I just kind of did that off the cuff. Okay? And so you have that. And now you divide everything by 3. And you get x is greater than 1, less than or equal to 5. See that? I'm going to keep track of those numbers. That worked out kind of nice. -2 and 10. Okay? Let's try another one. Let's try 5 minus 3x is less than, I don't care, let's say -14. Let's make this less than or equal to, and, this is less than or equal to this, and this is less than -3. Let's just make it -3. Okay? So, what do we do here? Well, first of all, notice I'm going to have to subtract 5 from everything. So I'm going to subtract 5 from everything. And when I do that, I'm going to get what? -19 is less than or equal to -3x. Subtract 5, I have -3, and I subtract 5, it's going to be -8. Everyone agree with that? And now we're going to divide everything through by -3. So I'm going to get my x here. Remember, we're going to have to change our signs now. And this is going to be 8/3. And this is going to be 19/3. Okay, so x is greater than 8/3 and less than or equal to 19/3. You might prefer writing it like this. I usually like to write them in this order instead. And so basically it's saying what? It's saying here's 0, here's 8/3 right there, there's 19/3 right there. And so what are we told? We're told that x is somewhere greater than 8/3 and less than or equal to 19/3. So if you wanted to, you could say it's all the set of all x's such that x is an element of what set? From 8/3 to 19/3. Okay? And that's a bracket right there. Okay, very good. Let's try one more. I think this is one from the book, if I'm not mistaken. Just to show you what you can do. Let's go 5 times the quantity x minus 3 minus 7x is greater than or equal to 4 times the quantity x minus 3. What? X minus 3 again? I don't know why I have x minus 3 both of those places. Let's make it x minus 2 this time. Let's make it x plus 2 this time. Plus 9. Okay, so let's see once what solves this. So first I'm going to multiply this out. So I'm going to get 5x minus 15 minus 7x is greater than or equal to 4x plus 8 plus 9. Agreed? If you multiply that out. Now let's combine these together. I have 5x minus 7x is going to be a negative 2x minus 15 is greater than or equal to 4x plus 17. And now I can add 15 to both sides. If I add 15, we're going to get 2x, negative 2x. If I add 15, I'm going to get plus 32 here. And then, let's see, I'm going to subtract 4x from both sides. If I subtract 4x from both sides, I'm going to get negative 6x, like that. And finally, let's divide both sides by negative 6, and so we're going to get x, remember we have to change the sign, 32 over negative 6. And so you could leave it like that, but I notice I can reduce that. First of all, I can bring the negative up on top and write it as 16/3. Okay, so that works. That worked fine. As I was doing the problem, it occurred to me, remember the answer there. I think a better way to have done it, once I had all this, would have been to have added the 2x on this side. If I add the 2x there, and if I subtract the 17 over to the other side, if I subtract 17 from, well, if I subtract 17 from both sides, I'm going to get negative 32. And I like this way better because then I've got a positive 6 there and I don't even have to worry about changing the sign. See that? So if you can make life a little bit easier for yourself, you're going to get might as well make life easier for yourself. Okay? So you can write it like that, or you could write it as x such that x is an element of what? It's less than or equal to negative 16/3. So there's what it is. Everything less than or equal to negative 16/3. You drew it on the number line. Say like that. If you put in a dot, like a solid dot like that, it means you're including that point. If you make it without filled in, that means you're not including the point. Like that. Okay, very good. So that's a quick introduction to inequalities, and as always, you'll learn more of these in class to get a lot more practice. this is a good opportunity to really master something. You can get kind of the initial understanding here, and then you really master it in class, or you can first get it in class and then use this to get some review. But if you both use these videos and also take advantage of your instructor, you'll really master this material. Very good.